And welcome back, and we're on to the 9th of Feb, further maths 5 a day, and let's go with the first question. Okay, so we have a pretty standard further mathsy type index rule question here, whereby we have powers, but notably, I say notably, hopefully you do recognise that 3 seems to be the key number here. So if I change everything to a 3, and then I just use my index rules, it should fall out quite nice. So let's do it where I have space over to the right. So 81 is the same as 9 squared, so therefore it's going to be 3 to the power of 4, and then that's to the power of x, so it's 3 to the power of 4x. 9 is the same as 3 squared, so I can say this is the same as 3 squared, and then x plus 1, and then 3. Now this is the bit that everyone gets wrong. So 3 is the same as 3 to the power of 1, and 3 square rooted is 3 to the power of a half. So let's tidy all these things up now. So let's deal with the left-hand side. So I've got 3 to the 4x. Divided by means take away. So I'm going to take away the expansion of 2 times x plus 1. So I'm going to take away 2x and take away 2. And that's equal to, on the right-hand side, 1 plus a half, which is 3 to the 3 over 2. In other words, 1 plus a half. Now, because the base values are now the same, I can effectively just equal the index values. So that means I'm going to go back over to the left again now because there's a bit more space here. So that means 4x minus 2x minus 2 is equal to 3 over 2. 4x minus 2x is 2x. Add 2 to both sides is going to give me, well, 3 over 2 plus 2 is the same as 3 over 2 plus 4 over 2, which is 7 over 2. Divide both sides by 2, and that's going to give me 7 over 4. Good starting question to get warmed up today. Next question. Okay, so what do we have? So it's obviously a pattern question. How many of these tiles are needed to make pattern number 12? Now, because I'm adding hexagons to the outside of the pattern, I'm guessing this is going to be quadratic because I'm not adding the same number each time. I'm adding a growing number. Now, the way to approach this is just to write down the first few numbers. So the pattern 1, what does it need? It needs just tiles, so not just pink or yellow, but tiles in total. So pattern 1 has 1 tile. Pattern 2 has 1, 2, 3, 4, 5, 6, 7 tiles. And pattern 3 has a 7 plus 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yes, 19 tiles. So I've got the first few terms of my sequence. Now we're going to have to make a bit of an assumption here that the pattern follows from only 3 numbers, but I'm sure it does. So 1 to 7 is 6, 7 to 19 is 12, and it appears to be going up by 6 each time. I am going to have to assume it's quadratic. There's no proving this here. There could be a further part of it. If this is a maths question in GCSE, or indeed in A-level, there'll probably be some element of proving or showing rather than just assuming this is quadratic. Either way, let's go with it. So that means my second difference is 6, which means my A is going to be 6 divided by 2, which is going to be equal to 3. Right, I'm trying to work out how I can do this because I don't have a lot of space. Maybe I'll go to the right, it might be easier. So if I rewrite the numbers I have, I've got 1, 7 and 19. And then underneath, now if you haven't seen me do this before, the way that I do this is I write 3n squared, or whatever the A term is, underneath my sequence and take that away. Because I know 3n squared is part of my sequence already. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. And 3 squared is 9, times 3 is 27. Then if I take these numbers away, 1 minus 3 is minus 2. 7 minus 12 is minus 5. And 19 minus 27 is minus 8. So you can see the difference here is 3. So again, I'm making a bit of an assumption because I don't have enough terms to really do this properly. But nevertheless, this sequence at the bottom, so in other words, this sequence here, I can say is, well, I'm getting more negative. So it's minus 3n. What do I do to get from minus 3 to minus 2? Well, I'm going to add 1. So in other words, this is taking me quite a while to get here. I'm going to move this over. I can say my nth term, so my un, is going to be the 3n squared from the a I got before, minus 3n plus 1 from the linear sequence I've just worked out. And I still haven't done the question, have I? Because I need to work out, I'm going to have to go over here, I need to work out what U12 is. Now you'll remember, because it's now hidden over here, it's 3n squared minus 3n plus 1, so 3n squared minus 3n plus 1, which means that U12 is going to be 3 times 144, 12 squared, minus 3 times 12 plus 1. And if I get my calculator out quickly, that is going to be 3 times 144 minus 36 plus 1, which is going to give me 397. And that is going to be my answer to this question. Not an easy question, but equally not too difficult and definitely in the ballpark of the sort of things you need to know. Next question. This looks like a Pascal's triangle question, doesn't it? The coefficient of x squared in the expansion, 3x plus a to the power 4 is 1350. Work out. Now, the key thing about these questions is, well, first of all, let's do Pascal's triangle. So I need the fourth line. So 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Frankly, you want to be good down to the fifth row at least, and just be very aware of what the numbers are so they don't surprise you when they come out. Anyway, I don't want to work them all out. I only want to work out x squared. So if I think about 1, 4, 6, 4, 1, and I think about if I were to do the expansion, this is going to be 3x to the power 4. I don't want that one. That's going to be 3x to the power 3. I don't want that one. And this one is going to be 3x squared, and I do want that one. So this is the line I'm going to concentrate on. So it's going to be 6, which is my sort of coefficient of the expansion, if you like, times 3x squared times by, well, if the overall power is 4, 4 minus 2 is 2, so that's going to be a squared. And if I multiply all these things together, I get 1350. So I can basically tidy this up, can't I? Now, just as a slight aside, I've left the x squared on the left and I haven't got the x squared on the right. Technically, the coefficient is without the x squared, but it's kind of hard to explain without writing everything I've written down. So let's now tidy this up. So 6 times 3 squared times a squared is equal to 1350. Let's divide both sides by 6 times 3 squared, so 1350 divided by 6 divided by 9, thankfully equals a nice square number, so that's a squared is equal to 25, which means that a is equal to 5 or indeed negative 5, because they will both work because it's a squared term. So therefore a is equal to 5 or is equal to minus 5. Good question, with a nice little catch at the end just to make sure you don't lose that extra mark. Next question. 2 more to go. Sketch the curve. Now, this is just one of those skills you learn. If something is factorized, that means you can find out what the roots are. And the roots are where you cross the x-axis. So in other words, this is going to cross at 6, at 1, and at minus 3. In other words, the thing that solves the bracket to make the bracket equal to 0. So roughly, not precisely, I'm going to sketch minus 3, let's call that there, sort of to scale. 1 is here and 6 is here. And I'm going to label these because, well, that's part of what we do when we sketch. So that's minus 3, 1, and 6. Now, I'm doing x times x times x, so that's x cubed. So therefore, it's going to be a positive x cubed. So it's going to look something like, and let's try and do this correctly, something like this. Now, let's just quickly check what it needs. So label the points where the curve crosses the axes. So it's both axes. So we also want this one here, and that is going to be. Now, if I put 0 into each of these, I've got minus 6 times minus 1, which of course is 6, times by 3, which is 18, which means that this value here is 18. Good question, good understanding question. Just be clear about one thing. This is a sketch question. So you want those sketches to be good. Don't sort of rush the sketch because that's the whole point of the question. So nice, smooth, in this case, cubic curve. Next question. The point A lies on the curve that the x-coordinate of A is minus 5. Find an equation, the normal to the curve at A. Okay. Normal or tangents mean differentiation. So the first thing I'm going to do is differentiate. I'm going to find dy dx. And I'm going to do it here because I suspect I'm going to need some space. So if I differentiate, so x squared becomes 2x, plus 2x becomes plus 2, and the 10 goes away because it's x to the 0, and anything times 0, it becomes 0. Then it says the x coordinate, so I want to find out the gradient, so I want to find dy dx at the point where x is equal to minus 5. In other words, I'm going to do 2 times minus 5 plus 2, which is minus 10 plus 2, which is minus 8. That's the gradient of the tangent, which means the gradient of the normal, m subscript n, is going to be minus minus, which is plus. 1 over 8 is an eighth, so therefore it's going to be plus an eighth. Now, 2 methods here. You can either do y minus y1 equals mx minus x1, or you can just do the mx plus c and find c. I tend to think at this stage that doing y minus y1 equals mx minus x1 is a little bit easier, because the question doesn't tell you what format to put the answer in. So I'm going to do this. So let's use the point. Now actually I've just realised I can't do this yet, can I? Because I need the y value. So I also need to put the x value into here to find the y value. So y is equal to minus 5 squared, which is 25, plus 2 times minus 5, which is minus 10, and I'm going to add the 10 back, so that's going to give me 25. So my y value is 25. So therefore, going back to here, that's going to be y minus 25 equals an eighth times x minus minus 5, which is x plus 5. Multiply both sides by 8, which is going to give me 8y minus, well, 25 times 4 is 100, so 25 times 8 is 200, equals x plus 5. And underneath, I'm going to write my answer neatly. So that's going to tell me that. Well, I'm going to move the x to the other side. So minus x plus 8y minus 205 is equal to 0. Or x minus 8y plus 205 is equal to 0. You can, of course, just write it in terms of y equals mx plus c. The question doesn't tell you what to do. I think this is a little bit easier. Sort of gets rid of the whole fraction being a bit of a pain thing. But either way, if you've got some that or equivalent, well done. And if you got all of today's answers correctly, well done. A nice little mix of questions today, as ever. I think this month is definitely much more varied than we saw last month, and I think this trend will continue as we go. Like, subscribe, usual thing, comments below. I will answer your comments, and I will see you for tomorrow's video. Thanks all.